I got this thing. Let me double check. I'm not in something I shouldn't be. Okay, good. I got this thing. So I don't want to spend a lot of time on this one. It's like plot these points. This is literally what this thing is. I'm hoping you can do this. You can go, what, 3 right and 1 down. You can go 3 left and 1 up. So I want to show y'all maybe a little bit about how to do it on here. And so I went to Desmos. I went to desmos.com. If you go to, let me show y'all. Start off at Desmos. Yeah, whatever. So if I want to go to desmos.com and I want to do a graphing calculator, I think it's just this button right here as well. So if you want to graph stuff, you can do it here. This is a good place to maybe do some stuff. -1, 3. And so we were doing T-charts. And so if you want to do a T-chart, you can do a T-chart in Desmos -3, comma 1. So I'm being a bit lazy, maybe. -2, comma 0. -4. Ooh. -3. 1. Woo, and 14/5. So 14/5, maybe if you don't know where that is, what is that?
It's almost 3.
Yeah, almost 3. 15/5 would be 3. It's 1/5 less than that. I think is the easy way to think about it. I was trying to like give them a sort of easy way to think about it.
Well, I found when I'm trying to graph any kind of fractions is that I try to turn it into a mixed number first. I think it makes it easier.
Yes, that is good, but something with like notation and mixed numbers, if you're writing it out symbolically, we try to steer away from mixed numbers, and I'll talk maybe a little bit more about that. But I want to look at this. So if I want to do x-axis, it's going from -10 to 10 in the x-axis. If I want like every single step in there, we can do by steps of 1. So now it's counting every one. Y-axis, I don't know. Let's do it the same. -10 to 10. Do steps of 1. What happened? Oh, I did a double negative. Sorry. Whew. I don't like those minor grid lines. We can take those out. So there's a few things you can do and play around in here. You can add arrows to maybe your grid. The best way to learn is to get like your hands on it. I don't know what else to tell you on that, but try these things out, see what it does. So this should be what, problem 3. Let me stop my screen share.
And let me just tell you, you do need graph paper of some sort for this. A lot of times people try to freehand these things, just on a piece of non-grid paper, and it's usually not very pretty. So really, I would really encourage you either to use Desmos and then copy and paste it onto your homework, or get some grid paper.
Yeah, and the other thing you can do if you have access to a printer, you can literally like just Google free graph paper and find a site to print graph paper from as well.
Yeah,
I did that for a few of them for today. What does it say? So 7 says, is this ordered pair a solution to the equation? Is the point on the line? Okay, so I want to just like maybe get this out of the way so we don't have to keep answering 2 questions. What do each of those mean? How do those relate to each other? If we have this equation, what does it mean for this point to be a solution to this equation?
It's a, well, when you have a 0, that is called the intercept.
Oh yeah, but like in general, like what does a solution mean to this equation? Like it's a number that does what to it? How do you know
how do we know if it's a solution? You'd have to plug in the numbers.
Yeah, and then it makes what, a true statement, right?
Yeah, or maybe it's not true. Maybe it's like,
but if it's not true, then is it a solution?
No, it's not. It's a contradiction.
Okay. So if it's not true, then it's not a solution. If it's true, it's a solution. So a solution is something, if you go plug it back in, it's going to make it true, right? And so if we plug it in, it's going to make this equation true. This equation, if we take a point on this line, what do we know about like that point on that line relative to this equation, I guess is what I'm asking. Like, how does a point on the line, on this line, relate to like a something that makes it true? How do these things all relate?
Well, I mean, each point on the graph, like on that
Mhm.
line you drew, I mean, I'm just guessing here, it corresponds to all these A, B, C coordinates here. So let's say it does, and then you can take each one of those and you can plot them into that equation.
And it's going to make it true, right?
Well, it should. I mean, of course,
Should.
I guess you'd have to
Okay.
work it out. So let's say it does.
Because
So,
what this represents is it's an equation that represents this line, right? So if we take
mhm,
any point on this line and go plug it back in, it should be a point that makes this thing a true statement.
mhm.
It's saying one and the same thing is what I'm trying to get at, right? If it's an ordered pair, if solution to the equation, then it is a point on the line, and vice versa, right? These things are equivalent, and so this line actually represents all the solutions to this equation. It's just a
Yeah,
graphical representation of it, right?
yeah. And then also you have two variables. Therefore, you can continue to change the numbers. But if you only had one variable, it would be conditional, and then you couldn't plot a graph with it because basically only one thing could be that variable, and you couldn't continue to change it over and over again. Unless it's a, what is it called? I forgot what it's called, the identity. But I don't think you can plot an identity either, could you?
Um,
Not on a graph. That would be more like a line graph or something.
that will the identities will come in more when we have like systems of equations, when we have multiple lines.
Mm.
Um,
And we're only going to stick with two variables because this is a graph that has two dimensions to it.
yes, if we start getting more variables in here, we're gonna have to start putting more dimensions, and the graph is gonna become more complicated, right?
Right.
Yeah.
I guess it can only go up to three, I guess, unless you want to start going crazy.
Yeah, I mean, Sagan has a bunch of videos about more dimensions, but they're kind of crazy, and I'm not sure I understand them very well, to be honest. Uh, it's weird stuff, but
Well, when we get into matrices with three equations and three unknowns, we'll get into the third dimension.
so is the order to pair solution. So we talked a little bit about that, a little bit to find that. So if you want to, like, we plug in these, we see if this thing is true, right? And so for part A, I'm hoping your work looks something like that. The other way we can check it is we can look at this thing, 0 minus 3. Is that a point on that graph? Yeah, seeing
Yes.
that nods, yeah. Okay, so yes, it's absolutely a point on the graph. So is it a solution? Yeah, it should be if it's a point on your graph. So there's two sort of ways you can check this thing, and I think that's what this problem is getting at. If you want to check, you can check the minus 2 is equal to 1 times 2 minus 3. What is that? 1 minus 2? 1 minus 3. So those two should be solutions. So 2 minus. So I think they want you to do algebra and do some symbolic stuff. Personally, if they gave me a graph, I would not be I would not be doing that. I would just be looking at the graph and seeing if it's a point on the graph. So minus 2, minus 4 is what I would do. It looks like it's a point on the graph. I did 2 of them already. I don't feel like doing that other one. But if I do 4, 1, what about that thing?
No, it's not part of the
Yeah.
line.
Yeah,
Yeah. It's,
not a solution. So this is what 4, 1 is over here. So definitely not that thing, right? Well, there's X. Are there any questions about this one? Okay. How many people? Okay, so I think this one wanted to say, in the following exercises, graph by plotting points. So for these things, 11, 13, and 17, oh, look, he even gave you 3 little graphs there to do them on. Look at that. How nice is that?
I don't always do that.
So this one, should I break it off into groups? This is what I'm debating. Slept through the alarm. All right. But sometimes that happens. Okay. Okay, so let's go ahead and do this. Like, go ahead and make up your T-charts. Make up some numbers. Make a T-chart. Pick an X. I think I'm gonna put you on breakout rooms of what, 4?
And you can definitely use Desmos for this one too. I mean, right? Wasn't that what you were showing them earlier?
They should be doing the T-chart for this.
Yeah, but you can do a T-chart.
You can do a T-chart in Desmos too.
Yeah.
But I'm hoping they crunch some of those numbers by hand, to be honest.
Okay.
Yeah, but you said we don't need a graphing calculator for this class, right? We can break it down and just do our regular calculators on it.
Right.
Yeah, I'm not gonna break it all into groups. I'm just gonna give y'all some minutes on this, and then pick on some people.
Okay.
So do it.
And you can, and we're going to give you the TI emulator because ACC paid for it, and you can also do this on a TI emulator really easily.
Y'all be ready to answer too, man. Y'all need to be like, there's this thing we can do on like Zoom. If you have it on mute, you can just hit the space bar, and it's kind of like a walkie-talkie. It's pretty great.
I didn't know that.
Yeah.
Is this like a rise of a run, like slope-intercept form?
And they are, but that's not the way we're graphing them in this section. It's the way we graph them in the next section, totally. But this section, we're pretending like we don't know that. So do a T-chart. These little things with the X and Y. Let's do X minus 1. 1.
So I guess first one we're doing is 11, right?
Yeah.
According to the, okay.
3x minus 1. We're doing a minus x minus 3. And a half x plus 2. Ooh, I have an idea.
Oh, we want to start with 0, right?
That's, you don't have to, but it's a good number to start with. It's definitely one of my favorite numbers. Mostly
Okay.
because I'm lazy and it's
Because
easy.
these graphs aren't that big. I'm just figuring you want to stay as close to the center as you can.
Yeah, typically you want. This is my strategy. I throw in a 0. I throw in a number larger than 0, and I throw in a number less than 0. Positive, negative, and a 0 is what I usually do. If there's a fraction in there, I try to pick really pretty numbers so I don't have to deal with fractional amounts. So how many solutions are there to a linear equation, usually?
From what I understood, I thought it was like infinite.
Ah, yeah, there's infinitely many points on a line that we can pick, right?
Yeah.
Mm. If y'all could just like focus on getting them points or the points, and then I think that's the main thing maybe to focus on right now. And then y'all can graph it after that. But I'm gonna ask y'all for points. So have a few of those prepared.
Do you want us to do like 11, 13, and 17 all at once?
I can't hear you.
Do you want us to do 11, 13, and 17 all at once?
Yeah, 11, 13, and 17. So you have 3 different graphs to do.
Okay, thank you.
And so like find some points that are on that graph. My dog gets real anxious when it rains and thunders. Okay, I think it's time to like start doing this a little bit. I'll share this screen. Okay, so 3x minus 1. If x is 0, what is my y? That should be the easy one, right? Who has it? Michael? I see your head down there. What do you say?
What'd you say?
If
Which
x
one
is
is?
0, can y'all see my screen?
Yeah.
Okay, I should be sharing screen.
Which number is this?
So I'm doing number 11. If
Oh.
x is 0.
I got -1.
Okay, so what other numbers do you have? X's.
I mean, I just go -1, +1, and then ended up with -4 and +2.
-4 and +2. Right. 3x minus 1. Let's see. So we're doing. So if we plug in -1, it should be what? 3 times a -1. So you're doing 3x minus 1?
Let's see here. For 11. So when I got x is -1, I got -4 because 3x is -3.
-1, -4 is that what you said? Okay.
Yeah.
And
1 and +2.
so if we do -1, that should be what? 3 times the -1?
Yeah, that's -3. -1 is
Okay, yeah.
-4.
And then you said what else?
I got 1 and 2.
1 and 2. Okay. And we're doing 3x minus 1. Okay, those look like the check. Can we see these points? How they differ? Can we do a different color? I don't know. We can do a different color with this line. I know that. There we go. If we hold on it, you can make it different colors. I think we can do it with this thing. Here we go. Can make it green. I think they just come up as gray because they're overlaid. No, there they are. 3 points. So Desmos might be a good way to also check if they're on the line. Who else is next one? Leslie, I see you down there. Are you around?
Yeah, I'm here.
So let's do number, what, 13?
Okay. So I got with negative, so I did -2 and then -1 for y. And then I got
-2.
Yeah.
-1, is that what you said?
Yeah. And then I got -1 with -2.
-1 is a -2.
Yeah, and then I got 0 and then -3.
You said 0 and a -3.
And then 1, -4.
1 minus 4. So you really went
And
4.
then, yeah, and then I went 2 to -5, and then that's
Woo!
it.
Now you're really going for it. So
Yeah.
technically, we need like what, 2 points to make a line at the least, right? I typically like to get at least 3 points. Make sure it's straight, and it helps a little bit. You went for it full force. That's good. Okay. If you know like your slope and your intercept and how slope and how slope and your y-intercept work and all that good stuff, it's not too hard to figure this one out either, right? We're going down 1, over 1. I don't know.
So I had a quick question.
Oh yeah.
So if it's a negative x, so if we wanted to put a -2 in there, we put that pretty much in parentheses and then make it a positive?
Yep, exactly.
Okay.
It's like a -1 times that -2.
Okay.
Yep. And the last one, is X awake now? Xavier?
Yeah, I am awake now.
All right. Okay, so what are some points for this last one? For 17, I have X plus 2.
Could you repeat that? You kind of cut out at the end.
So I have this last equation, number 17, is 1/2 X plus 2. Can you give me some points on that one?
Yeah.
I think 0 is the easy one, right? 0.
It's just gonna be like 0 and 2.
Yeah.
And then from there, you're gonna go up 1, 2.
You did it with slope. Okay. I would plug in, if I'm being honest, I'd plug in like -2 and 2 is what I would try to plug in.
Oh, okay. Okay.
So you plug -2 into the equation, what happens? You're going to do 1/2 times of -2. Will give you what? -1. -1 plus 2 will give you what? 1.
1.
And this other one is going to go to the other side. Is going to be 2 times 1/2 is just going to give you 1. We're going to do 1 plus 2. I think it should be 3.
Oh yeah, that makes it a lot easier.
Yeah, so if you pick your like numbers to be like multiples of the denominator, right?
Yeah.
It would be a little bit easier plugging stuff in. So I'm going to do that because it's just easier to type in. But 0.5 is 1/2 plus 2. It looks like all those points are on there.
Yeah.
All right. That should get us problems. Where are we at now? Stop this share. And I want to look at this. This is 15, 16, 27. Is that froze? Y'all can't see anything on there, huh? I think my camera froze. Yep. Let's see if I can restart my camera. Uh-oh. Guess not. Okay.
I gotta step away here. I gotta cut.
Okay. I gotta restart my phone. Okay. So let me try to do my other camera. See if I can see it on here. So maybe. That's horrible, isn't it? And that's reversed. No, I think. So 27 is the next one we want to do. I think if I just do screen share, So x equals a -2, what does that look like? And I talked about that in the notes. But if you do an x equals -2, is that, these are the special cases of like vertical, horizontal. Which one is that? Is that going vertical or horizontal?
That one would be vertical, right?
Yes, and so hopefully you watched the video. We're thinking about this thing like a grid system. So x is measuring left to right. In order for things to go left to right or to measure left to right, we have to make the lines vertical, right? And sort of if we're measuring up and down, we have to make our lines horizontal. So the other thing would be like y equals what, -5. That's all they're asking for that problem. The following exercises, graph these things, okay? And so another way like they like to really do things is like they like to give you the point and then they like to ask you for the equation of the line that is horizontal, the equation of the line that is vertical. So that's another way that they kind of like to phrase things in this book. And so you should be able to do that. If we want the vertical line, it's the x equals, right? If we want the horizontal line, it's the y equals, and it's the number that's there. Okay. We did 3, 7, 27, 33, 35. We got 5 more to get through. Let's see if this thing is back up. It's still starting. Okay. I still have to work with it. Oh, 33 and 35. Y'all should be able to do those. It says find the x-intercepts, find the y-intercepts. Am I back up on this thing? I think I might be back up on my phone. Let's see if it works. Okay. And I think we might be back in business now. Okay, good deal. Please stick with us while we're experiencing technical difficulties. Okay. And switch to this camera, and I think I'll be good. Here we go. Find the x and y intercept. And so I ranted a little bit about this in the lecture notes. But if I'm talking about the x and y intercept, please don't give me just a number. If I want the x-intercept, that's when 1 is equal to what?
X and Y.
What is my x-intercept there?
Let's say 0.
3, 0. So the x-intercept is when your y is 0. The y-intercept is when your yeah?
0, 3.
0, right? Okay. 0. Yeah, 3. Okay. I had to double check the same number. A little confusing. But the x-intercept is 3, 0. The y-intercept is 0, 3. So a lot of times people will just tell me like the number 3 or something. You should really put a point in there so I know that you know what you're talking about. Because it really is the point when we talk about the intercept. And the entire point is that it is the point, right? Okay. So when it's the x-intercept, the y is 0. When it's the y-intercept, the x is 0. So if we need to solve things symbolically, that's the way we're going to solve things symbolically. We're doing things graphically on here, so don't think too much of that right now. I want the x-intercept and the y-intercept. Who has not talked? Olivia, are you around?
Yeah, I'm around.
What's the x-intercept here?
I got 5, 0.
Yeah, that's it. And what's your y-intercept?
I got 0, -5.
Yeah. So it's a horribly drawn 5. It's there. Questions over this, over how to find x and y intercepts? If you want, this is also another way you can graph your line. Technically, you only need 2 points. So one way people graph things really quickly if they need to is by finding just your intercepts. It's easy to plug in 0, right? Usually.
So when you want us to find x-intercept and y-intercept, you want us to like put it in parentheses instead of just putting x equals 5 and y equals 3 or something like that?
Absolutely. Okay. Are these the last 3? Okay. So this section, they want us to graph using the intercepts. So find your intercepts, do T-chart, graph these things. I'll give you a little bit of time. Are they? Oh, they are totally doing that to you, like they. I like it. Okay. Who's next? Paige.
Um, I will. Can I pass? Can I pass?
I'm gonna walk through it with you if you want. If we're gonna do, it shouldn't be too difficult. Let's do it. If we plug 0 into x, what is that going to leave us with? So this x is going to simplify, right? It's just going to be 0.
Mm-hmm.
And that's going to leave us with what? 4y equals 8? So 4y is 8, then what is y?
2.
Yeah, that's it. And then the other thing, what if y is 0? So if y is 0, I have negative x plus 4 times 0 equals 8. So this thing is no more. I just have a negative x is equal to 8. So x has to be what?
Positive. Oh, is it just 8?
Yeah. If negative x is a positive 8, then positive x is a...
-8.
Yeah, that's it. You got to swap the sign on them. Multiply by -1, however you want to think about it, right? There's a sign swap. So these are my my x-intercept and my y-intercept, my two intercepts. Whew. And if I want to graph these things, okay, I guess I'll throw my graph up on here. I want to graph these things. I have to go by 2, so I have to do 2, 4, 8 to 8. I think I'll have to do that. So 0, 2 should be 0. And then I have my 2 points. That's what I got to do. Good. I can't draw a straight line to save my life, so I'm not expecting you to. Oh, I'll give you those answers. Anybody got questions on how to do these things? We're plugging in 0 to 1,
So
we're plugging in 0 to the other.
Basically to find the y-intercept and x-intercept, you gotta like simplify the equation first and then just plug it in or whatever.
Yeah, so you're plugging in 0 to the x, right? And you're plugging in 0 to the y.
So yeah, so in this case, if my x was 4, technically my x-intercept would be 4. Kinda.
And so when my x was equal to 0, my y was 2, right? And so this is 1 point that we're getting out of here. And when my y is 0, my x is 8, right? So I plugged in that value and I got this value, right?
So kind of like, what's it called? Substitution.
Yeah, you're plugging it in. Yeah, you're substituting in the value, right? And this is the value of the y, and it gives me this value of the x. And so I think I've maybe like mentioned it like once or twice, but like pretty much all of math is like, it's an application of logic. It's an application of set theory. So we can think of things as like sets and relations. All we're thinking about is like, we have a set of number that is our x's. We have a set of numbers that are our y's. And this thing here, this equation that they're giving us is giving us a relation between those two sets of numbers, right? They're giving us some way to compare them. And so we can plug in one number and get the other, is basically what it's kind of saying. And it's giving us a certain pattern. That pattern looks like a line, right? Okay, so 51. Do I have them? Who's next? Timothy, are you around? Who's else? There he is. What'd you get for 51? We plug in 0 to the x, what is that going to give us for the y?
What are we, 51?
Oh yeah, yeah.
Okay.
It's open to anybody, I guess. If anybody's got it, we don't have too much time left.
Well, I mean, I got 6.
Yeah, so we plug in 0, we're gonna get 6, and so going over a real quick recap. 3 times 0 minus y is 6. We get minus y equals a minus 6. We get y is going to be the positive 6. That's how we're getting that. So my x, when my x is 0, my y is 6. The other thing I gotta do is what? Plug in 0 here. And if I do that, we're doing what? 3x minus 0 equals a minus 6. And if I'm doing this, what I'm seeing is my 3x is a minus 6. So my x should be what? Minus 2? Zero 6. Same thing. I'm probably going to label 1 by 2 for 6. Minus 6. Minus 2. 1. Okay. Move it up a little bit. So 0, 6 would be 0 left and right. 6 up. Minus 2 comma 0 would be back to no up and downs. Grab your rule, declare your status. Okay. And the last one. I feel like they're trying to trick you a little bit maybe on the last one. If we do y equals a minus 2x and we plug in 0, what happens? And this happened in our lecture notes, so it is something that does happen. But if we plug in 0, what are we going to get for our y?
0.
0.
Yeah. And if we plug in 0 to the y, guess what we're going to get for the x?
0.
Yeah. So either way we go, it's going to give us 1 point. And so if we were trying to graph this, oh man. So how do we get another point for this thing?
I mean, I just put it 1 dot right in the center. I mean, I guess that's all you can do.
No, this is supposed to be a line. How are we going to get another point?
I got just because of the slope that it would be 5 over 1. So I made another point with that.
You can do it with slopes, but I don't know what a slope is. We're not doing slopes until next chapter. So if I want another
We'll just
point,
using the only variable then.
well, 0.
I mean, I just got
0 gave us one point, right? And if we plug in 0, it's going to give us 0. And so by coincidence here, like the origin, right, is both the y and the x-intercept. And so what we need to do is we need to pick another point. And so to get another point, we need another number. I don't know how else to lead into that. So 1 times minus 2 is a minus 2. I guess we could go minus 2, 4, or something like that. I don't know. But basically, you're going to have to pick another number if getting your intercepts gives you 1 intercept, right? So I think I did 1 minus 2. Because it's the last problem. And the professor probably won't even count off for that because he's lazy. Oh, I missed my point.
So it just doesn't touch the axes and intercept them then.
It does. It touches both of them at one point called the origin.
Ah, okay. I see.
It's supposed to go through the origin. It's not the prettiest line, but yeah. And that's why it only gives you 1 point. It's because it's the same, right?
All right. So you just start plugging in numbers and you start getting results.
You plug in another number. And like, I know we're not there yet, but going back and looking at the problem, we know MX plus B format. Y'all keep on shouting that out at me. This is actually an MX plus B format. We just don't see the B because guess what number the B is?
0.
Yeah. And so it goes to the origin
It's
intercept.
kind of like non-existent, kind of.
Zero exists. It's
I
zero.
mean, it exists, but it's not like a number that's going to be like a point, I guess, or like
No,
on the graph.
it's kind of funny because in math history, right, a lot of cultures, like, it took a long time to realize that zero was a thing. Because you would, like, starting math history, you would have, like, a stick with notches to indicate, like, how many sheep you herded, right, or something like that. And so it was like, let's talk about zero. What are you talking about? 0 sheep. It's like, what? Well, what are you talking about? There's nothing there, you know? And so it took people a while to realize that 0 was actually a thing that you could do. What are you talking about? Nothing. Well, why are you talking about it? I don't know. Oh, no. Timothy's mic ain't working. That's why he was silent. Okay. Okay, so I think I'm going to end the recording. That's like the end of the homework. That's probably all I need to put up on YouTube. Sorry. It's on Blackboard as well, I guess, huh?